Welcome everyone. I am Manas Nair, and in this session we are going to explore four essential concepts in operating systems: multiprogramming, multitasking, multiprocessing, and multithreading. Understanding these helps us to grasp how modern computers deliver speed, responsiveness, and efficiency. Let's dive in. The essence of parallelism. So, why are we learning this? Because modern computing demands parallelism, the ability to do more than one thing at once. From running multiple apps on your phone to processing billions of operations in a server farm. This is where these concepts come in. Operating system manages all this in the background. Their job is to juggle tasks, share resources, and avoid bottlenecks, just like a skilled traffic controller. Evolution of concurrency. Let's look at how these ideas evolved. In 1960s, multiprogramming. Back then, mainframes ran one job at a time. To improve efficiency, multiple programs were loaded in the memory, switching when one was idle. 1970s, multitasking was introduced. With time-sharing systems, users could interact with multiple applications at once. In 1980s to 1990s, multiprocessing was introduced. The rise of multi-CPU systems allowed real parallel processing. From 2000 onwards, multithreading was introduced. With multi-core processors, even individual apps began using multiple threads for smoother experience. Uh, Understanding multiprogramming. What is it? Multiple programs are loaded into memory. The CPU executes one when it's when it gets stuck, like waiting for a file, it switches to the next. Why is it useful? It keeps the CPU busy, maximizing its efficiency. How does it work? Via job scheduling, the OS decides which program runs next. For example, think of it like a single cashier in a store. If a customer pauses to look for their wallet, the cashier quickly starts billing the next customer. Let's explore multiprocessing now. What is it? Multiprocessors or CPU cores are available and each can run a different process at the same time. Why is it useful? It boosts performance and reliability. One CPU fails, other keeps going. Types: symmetric, all CPUs are equal. And second, asymmetric, one main CPU assigns tasks to the others. For example, consider it like a restaurant kitchen with four chefs, each making a different order at the same time. The result is a fast service which everyone can enjoy. Let's delve into multitasking now. What is it? Multitasking Multitasking allows concurrent task execution. Multitasking lets one CPU simulate during doing many things by quickly switching between them. Why is it important? It gives a responsive experience. Users feel like everything's happening at once. How does it work? Through context switching. The CPU gives each task a time slot, switches to the next, and repeats. For example, consider it like a student studying three subjects in 1 hour, switching every 20 minutes. It's not truly parallel, but progress is made on all fronts. Let's understand multi-threading now. What is it? Inside one process or program, multiple threads run at the same time, often sharing data and resources. Why is it powerful? Threads are lightweight and make apps faster and are more responsive. For example, consider it like a video game where one thread handles user input, other handles graphics, other handles physics. The player experiences smooth gameplay, all thanks to threads, as all the threads run at the same time. These all threads have a shared memory. Threads for this system architecture comparison. Let's summarize how each concept works architecturally. Multiprogramming. One CPU, many programs in the memory. It switches based on input and output needs. For example, a waiter switching tables based on who's ready to order. Multitasking. One CPU switches between tasks and which is super fast using time slicing. For example, a DJ playing short clips from one multiple songs one after the other. Multiprocessing. Multiple CPUs work in parallel. For example, multiple workers typing different reports at the same time. Multithreading. One program with many threads working on different subtasks. Like for example, a painter who's working on background details and text simultaneously. Let's compare these parallel concepts. For example, um, the concept multiprogramming. Its key feature is one CPU. Its benefit is better CPU usage. Use case, batch systems, etc. Multiprocessing. Its key feature is multiple CPUs and multiple processors. Its benefit is performance and reliability. It is very highly reliable. Its use case is servers and supercomputers. Multitasking. Its key feature is single CPU and concurrent tasks. Benefit is its user responsiveness and it is used in different operating systems. Multithreading. Single processes and multiple threads. Benefit responsiveness, efficiency, etc. Its use cases are used in web browsers and games. And let's now talk about its real world applications. Let's connect each of these concepts with real tech. Multiprogramming. Payroll systems in legal legacy businesses. They run one task, then switch while waiting for the input. Multitasking. Smartphones, you can watch a reel, reply to messages, and upload photos without a lag. Multiprocessing. Google's data centers with a thousand of CPUs handling your search results in parallel. Multithreading. Games like GTA use threads for rendering scenes, managing AI, and responding to your inputs all simultaneously. Office analogy. To make it even clearer, let's visit the office analogy. Multiprogramming. One employee working on several reports switches to another while waiting for an email. Multitasking. One employee rapidly replying to emails, answering calls, and checking to reports in short bursts. Multiprocessing. Multiple employees each doing a separate task at the same time. Multithreading. One employee working on a big presentation. One thread writes content, one another builds the design, and another builds on adds the graph. Let's talk about the emerging trends. Where are we headed? Heterogeneous cores. Devices like smartphones use both powerful and power saving cores to balance performance and battery. AI parallelism. GPUs run thousands of threads to power AI models like ChatGPT. OS level optimization. Newer operating systems get smarter at choosing which tasks on which core. Quantum computing. Future systems may coordinate between quantum and classical processors, redefining concurrency entirely. Key takeaways and future outlook. Let's sum it all up. These concepts are foundation of modern computing. They help us maximize performance and user experience. As Technology evolves like multi-core mobile chips or quantum systems. These principles remain essential. Mastering them prepares you for careers in systems, AI, app development, and beyond. Thank you so much for your attention. I hope you now understand the difference between multi-programming, multitasking, multiprocessing, and multithreading, and how they make our digital world smooth and powerful. I am Manas Nair. Feel free to ask any questions you have in the comments. Thank you.